All right, so let's talk about rational inequalities. Now, we talked about solving quadratic inequalities earlier this year, but it's been a few months. The steps for solving any kind of inequality that's more complicated than like a linear inequality are pretty much always going to be the same. You're going to find any excluded values if the inequality has any. You're going to solve the related equation by replacing the inequality symbol with an equal sign and solving. You're going to place the excluded values and the solutions on a number line. It's called the number line method when we did it before. And then you're going to test numbers from the resulting intervals of the inequality to identify the solutions. So I'm going to give you a moment to pause the video and copy those steps down. Now, we did these steps when we were doing quadratic inequalities, except there were no excluded values back then. So let's look at an example. So the very first thing I want to do is to identify any excluded values here. And you can see that I've got an excluded value of x plus, I've got a factor of x minus 2 here, which means there's an excluded value that x cannot equal 2. All right, so now I'm going to work on solving the corresponding equation. Now, the corresponding equation, the related equation, is the equation you get when you simply drop the inequality and solve it as an equal. Now, we just watched a couple of videos on how to solve this. So you factor the denominators to get the pool. 3 doesn't factor. X minus 2 doesn't factor. 4 is 2 times 2. Now, if you notice on this one, they don't share any factors at all. So the least common denominator is literally going to be all these denominators multiplied together. So I'm going to multiply all the stuff by the LCD. Going to cancel appropriately. I'm going to multiply the stuff that is left behind. This is clearly quadratic, so I'm going to get everything on the same side. Oops, that's a minus 6, not plus 6. Now, I could solve this quadratic formula, but it happens to factor. And so x would equal 6, negative 1. So now I've got this excluded value and these two solutions. So here comes the number line part. So I'm going to draw a number line. I'm going to put these numbers on that number line in the correct order. And that divides the number line up into 4 intervals. Each of those intervals will either work in the inequality or will not work in the inequality. So I'm going to pick a number out of each of those intervals and test it to see if it works. So a number that's less than negative 1 might be negative 2. Number between negative 1 and 2 would be 0. Number between 2 and 6 would be 3. Number bigger than 6 would be 7. I'm going to plug each of those into the original inequality to see if they'll work. Now I'm only going to do the first one live, and then I'm going to do the rest of them with a video pause, so the video's not quite so long. So let's check negative 2. So I plug negative 2 into the inequality. That would give me negative 2/3 minus 1 over negative 4. And we're asking, is that less than negative 2 plus 1, which is negative 1 over 4? So this is negative 2/3 plus 1/4, because I've got 2 negatives there. So I'm going to combine the denominator. That'd be 12. So let's see, that would make that negative 8/12 plus 3/12. And I'm asking if that's less than negative 3/12. This is negative 5/12. Is that less than negative 3/12? It is indeed. So this works. That means that interval also works. So I'm going to pause the video and check the other 3 so you can see how this is going to go. All right, so I've checked the other 3 and I've marked the intervals that work and the intervals that don't. So my very last step is to write my answer, and I like to write this in interval notation. So this first interval starts at negative infinity and goes to negative 1. And I never include an infinity, so the parenthesis goes there. The negative 1, whether or not it's included, depends on whether the original inequality had an equal sign in it, and this one didn't. So none of these things are going to be included. If it did, then I would include it because it was a solution. Union. The next interval that works is this one, which is the one between 2 and 6. Again, the original inequality didn't have an equal sign in it, so I'm not going to include either of these. But if it had an equal sign in it, I would not include the 2 because it was an excluded value, but I would include the 6 because it was a solution. So there's a problem worked out. So now I'd like you to do this problem on your own and pause the video, and I'll come back and I'll have worked it out. Identify my excluded values. Solve the resulting equation. Get the LCD, multiply by the LCD, cancel appropriately, multiply the results, solve for x, draw your number line and put your excluded values in solution on them, pick numbers from each of the intervals to check them in the inequality, and you may occasionally have to use your calculator on that. I did on the last one, and then write your answer. And there you go.